So therefore I haven't used math in many, many, many years.
Okay, I'm starting the recording over for today, just a moment before we get to your question, but we had so much interruptions before, then it'll be a pain for someone at home if we don't. So the first thing we did was a project about foot size and height. That's our, let me grab it, foot size and height. So you were measuring for your group the foot length, the circumference around your footprint, the area of your footprint by stepping on a grid, and then how tall people are. And what we noticed was that the foot length didn't seem to be a good pattern. And when you tried a proportion, they were off by a lot. So taking the 6.5 and the 60, no, but I'll get there in a moment, and the 10 and the 70, that made a very far off proportion. Whereas when we compared circumference, the 24 and the 60 being compared to the 27 and the 70, then that was remarkably close for just measuring people's body types. So we spent a lot of time playing with this fun project. Hopefully it was fun. We started class before that with a question someone had about the wonder snail. So there were two things there.
I get how to do those. Those are pretty simple for me.
Yeah, so one is proportion.
I remember what you say about like putting the other one to cancel it out.
Mm-hmm.
But my brain stops at a certain point. Like, I know how to do it. I just have to practice more of those types.
Mm-hmm.
Because I get the concept of it, and when I see it, I'm like, okay, I remember you teaching that. And like, I know that I have to get rid of the yard so I can get into the other.
It is purposefully tricky that they both have the same snail, right? So one of them, there's two situations, this many yards and this many minutes is one situation, some unknown yards.
So what I have to say, like on your homework problems, how come, like even though I get it wrong, there's a right answer that I got, always. That confuses me.
Like, that's because I know what the mistakes people make. So when I make the wrong answers,
this is not fair. Like the answer's on there. I'm doing something right.
The number 19 doesn't have two situations. It's just this one speed, and we're just rewriting it in different ways.
Oh.
So that was the point of those. And we talked about that and wrote it all out nicely. Then we were doing a no calculator test. The first question was this weird one, number 8. How do you change things to and from percent? And this goes back to this one slide where there's 4 things that percent symbol can mean. So which one works? In this case, for this number 8, I want to take my percent symbol and replace it with a times 1 over 100, because that's the easiest thing to do with something that's already a fraction. If you reload the page, there's different ones that will come up.
So what would the answer be to that?
Well, 23 doesn't reduce with anything.
So it's just the same things, right? Oh, okay.
Right.
Okay, I think I remember. This is a little bit further back.
Yeah, so reload it a few times, see what format you're changing it to, and then go back to this thing about the different things you can replace the percent by. So review that if you need to from a while ago.
So reload the calculator, is that reloading?
That's the no calculator one.
So what I find best that I do
Mhm.
is I'll probably go print out a bunch of different ones, as I like to print them out and then they have the answer, so I'll just go ahead and go down and do that.
Mhm.
When I get stuck, and this is the only bad part about it, is like, I'll eventually, I won't, until I'll go through and do all the tests. And then the ones I got stuck on, like I'll look at the answer and then see how you got that.
It's probably better to print out like 6 of the versions of the test, like you say. Say you're pretty sure number 1 is a problem that you'll do on the real test. That's not one of the 2 or 3 you'll just skip and avoid, right? So I would do number 1 like 6 times. Check your work for number 1, make sure you really got that, practice that more if you need it.
Okay, so like take a bunch of these no calculator tests.
Right.
And the ones that I consistently get wrong, just practice those ones over and over because those are the ones
That's-
like,
those are the
if I'm
ones-
getting all the same ones right, then I'm pretty good.
And you won't retain what you're learning about how to do number one better if you're busy doing 2 through 19 also. So focus on one. And once you got number one, then do numbers 1 and 2 on the test and do that like 6 times, right? And then if you can get the first 2 problems right regularly, add another one.
Okay.
But don't look at all 19 problems at once because you're trying to learn too many things at once. Okay, back to the slides. We did reducing. It's a pain in the neck, but it didn't take that long when we did this in class. Then
So.
what's your new one you were
moral story
asking?
on those ones is like anything that's gonna take me a long time to sit there and plug in the numbers, I should probably hold off on those at the test and go to the easier ones.
do ones that are, first do ones that are easy and fast,
Mhm.
and then do ones that are easy and slow.
Mhm.
And then if you have to do some hard ones to get 13 correct, do some hard ones too.
Okay.
Okay, you had asked about the specific homework
And
problem.
I'm trying to get all my homeworks done so that I can actually,
So number 9 in justice percentages. So now justice.
I'm really just wanting to get these done so that I have a higher, I don't wanna settle with the C.
Mm-hmm.
I'm really hoping that I get a good enough grade that I pass and
So.
like, because I do understand how to do all this, but like my problem was I had so much writing homework to do that I focused on that a lot.
So you,
And I'm getting an A in that class, mind you. That matters.
here, let's do all 3 of the student problem ones, actually. We did one out loud together, but let's do it on the board. So first, number 8. So the picture we want to look at is,
And all we did was we just divided 45 by 35.
yeah, we had this picture.
35 divided by 45.
Is it gonna paste for me nicely? Yeah. So for number 8, our Mad Libs problem was what is 30, whoops. I'm sorry, no. Yeah. 35 is what percent of 45? Then we translated that, 35 equals y times 45. We wound up with 35 divided by 45. And we got about 0.78. If you can see in your head that all we're doing is taking 35 out of 45, writing it like a fraction,
And then you
and then
minus.
changing it into a percent with top divided by bottom, riplop, then that's what we're doing. Right? 35 out of 45, you could see it as a fraction in green, or you could fill in the Mad Libs thing. Those are both good. Okay, for number 9,
81.7. I need to get better at writing and not problems.
so again, our Mad Libs thing. Someone got 81.7 correct. And that was 86%. Right? There we go. So we don't know the total. Same as before, you like translating, so numbers stay the same. Is becomes equal. I'm going to take 86% and riplop it. Of becomes multiply, what becomes our letter? So I have something with times 0.86.
So you have to divide,
Divide by 0.86.
so, okay.
Okay, 81.
Is 90.
95, right? And it's a word problem, so I should label it. Oh, don't scroll box. Okay.
So basically on that one,
There's three.
because you don't, it's different because we don't know what it is, so we divide instead of multiply, like,
We were actually dividing in both cases, but it was for different reasons. The steps are always the same. If you're not sure about these percent sentences,
Is there
write out.
is there a way to tell by reading the problem, like, oh, I know that because of this, I'm gonna divide it, and then because of this,
Somewhat, but different people's brains do it better for different ways. You noticed that 35 out of 45 was a good fraction to look at. So your brain saw that this was the division problem without having to do the percent sentence. Most people can't make that same step for this problem. It's not as obvious looking at it which thing is on top and which thing is on bottom and what I'm dividing by and so on.
So what about
So
10?
let's do 10. Okay.
91%. Because I'm scared when I go to the test, my brain's not gonna like any of it, and it's just gonna be like,
Well, that's why we have these reliable systems that work even when our brains shut down on a test. So again, I write my Mad Libs thing.
well, you know, my brain hasn't taken any tests in many years.
Practice test, practice test. Okay, which goes in which spot now?
So, 40. Well, the percentage is obviously gonna be 91%.
Yeah, that's the easy one. Is the 40 the part change or new amount that goes here? Or is the 40 the whole original baseline amount that goes
The
there?
original baseline amount.
Yeah. So we're not sure how many they scored. What's the part that they scored out of the whole? That's the 40.
So that would be the X
The is becomes
times. No. Oh, no. Is dividing.
is equal.
Oh, equal. You're confusing me. Okay, so is always the equal.
Is always the equal.
Okay.
So is the equals.
Y.
Okay, of becomes times and 40 stays 40.
And then, so it'd be X, Y equals what?
So my y is already by itself. All I have to do is multiply those two.
Oh, so quite no. Okay.
So back in the beginning of the term, actually, no, not back in the beginning. In the middle of the term, we talked about percent of and percent change because some people have this strong intuition about those. If you don't, then the thing we did with percent sentences is the generic way to do these no matter what. So you can always make this process. Write your Mad Libs with the 3 blanks, fill in the
And of is
things.
always times.
Of is always times, is always equals.
Okay.
So fill in your 3 blanks, translate it, the times and the equals will always be there. And then do whatever it is, if you multiply two things, or if you have to divide to get y by itself.
Is there, okay, how do we get? Okay, no, we're moving on to the next one. Okay, so I think I did the first two of the measurement right. Okay. Because I wrote notes. Let's see. That. So to get it in there. So that's not, this is starting with Celsius, and this is starting with Fahrenheit.
This one is starting with Celsius.
Oh, okay, so that one would have been 1.8 times that plus Celsius after that. I'm just trying to get these, because I don't want to just get a C. I'm gonna pass this class. I have to think positive.
Okay, I'm gonna go back and see what else people wanted. No calculator at number 8 with the yarn. Okay.
Plus 32. Okay, yeah, that one, right?
No calculator.
I can't tell my daughter I failed math, so I have to pass. That's just it.
It's like, Mom, how did you fail math?
I did this wrong. Okay. 44 degrees. Oh, so 44 Fahrenheit minus 32 equals 12 divided by 1.8. 6.66666.
Okay, so in this problem, ignore me. I'm going to do this for someone at home while you
I
double
hate
check
this
yours.
problem.
Okay, well then don't ignore me. So we have two things that are 1/6. So whoops, come back.
Okay. Maybe I'm on balance. The square root is in size.
And she wants 40 seconds. So how many 40 seconds are in a sixth?
How many times 6 go to 42?
Yeah.
That's all it is.
That's all it is. How many times do I how many pieces do I chop each of those into?
It would only be 6.
Uh,
Maybe 6. No. No.
You're confusing yourself again, making
I
it harder
always do
than it
that.
is.
Why?
So we're going to zoom into that piece here, right? It's a blue thing.
So, okay. How many 140 is
6 times 6 isn't 42.
Right?
Yeah. What number are you looking for instead of 6?
That goes into 42.
2, yeah.
I'm not good at math in my head. The next one. That's why I can't do no calculator. There you go. My brain just hurts.
Okay, I'll just give it to you. 6 times 7 is 42.
It is.
Yeah.
I was gonna start adding on my fingers, but I thought you might look at me right because that's how I do it.
1, 2, 3, 4, 5,
My daughter
6.
knows her multiplication table and all that better than I do.
Mhm.
I'm like, what? So it would just be 7? Because it
All
actually,
right, so each of these is 1/42, and then the whole thing is that 1/6.
so it would be seven, the answer would be 7.
So almost. Let's go back to the problem after I finish my lousy artwork. Okay. So each stripe requires 1/42. How many
Okay.
stripes can she make? This bit here gives you 7,
Oh,
and then this bit here gives you another 7.
7%.
So this was 1 stripe worth of yarn. This was 1 stripe worth of yarn, and so on. I'm not sure why my little bars moved around. Okay. So she got 7 stripes for her scarf out of this bunch of yarn, the bottom of one skein. And then the other one gives her 7 more stripes. So 2 7s.
That's what it is.
Yeah, 14 total.
Why is that confusing?
Too close to lunchtime.
Oh, so okay, so you just add both sides. 7 and
7 and 7. Right?
Okay.
Because each of these
I'll give this one though.
little bits of yarn at the bottom of her spool gives her 7 stripes.
Uh-huh. Yes. I don't get that. I get it, but I don't.
Yeah.
I don't know why. My brain just doesn't wanna work.
Okay, we know you did the first 2 right for temperature. Did you have another homework question?
All of it. Okay. That square with sides 10 feet long has a top corner removed, like try to go by taking out on the top. How would we find that out? Those pictures you drew, right?
Mm-hmm. Draw pictures for them if it helps you. Trust this measurement. So I don't want to do them all, but we can draw all the pictures. So here's a square, and each side is 10 feet, and we're going to take a bite out of the top. So that's the shape I'm looking for.
I don't know how to get that, with those little sides, big 5.
No, and we don't need to know the sides. What's the area of the whole square, by the way?
Use that all the sides together.
That's the perimeter.
So how do I find the area?
Area of a rectangle.
I have to work on these ones.
Okay, memorize your area formulas.
Okay.
So
Yeah.
that was here. Oops.
Okay, total area. The triangle is half the base times the height.
Right, so what's the rectangle?
Length times the width.
Length times the, so what we were doing here, 10 times 10. This one had area 100.
So you just do the 2 sides, not all of one.
Right. If we labeled
Yeah,
more, it
it's
was
two
just,
sides.
for a rectangle, you only need two. If they label more, just ignore the other ones.
Because they're all gonna be measured the same.
The opposite,
then-
opposite ones will be the same.
And if I measured all of it, what is that called?
Perimeter.
Areas half. Two
Yeah.
sides.
If so, you don't need to know these blue diagonal lines. My hint is that if you draw the rest of the cuts, then you can see how to get from 100 to just the blue shaded thing. If this whole thing had 100 calories and you ate this much, then how many calories would you eat? Think about that. Okay, let's do number
25.
4. There's
Right.
25s in there somewhere. I'm not going to give it away quite yet. We have all next week. Okay, whoops. Now,
Now, probably. Because I
it's
got
circle of radius 6. So radius of 6 centimeters has its southwest corner removed. So this one, that's southeast. Let me draw it the right way. So what's the area of the whole circle? You remember that formula?
So I need to look over the shape thing.
Yeah, look over the shape things. So remember this thing with the 4 r squareds, and the area wasn't all 4 r squareds. It was just a little more than 3 of them
Pi times
times
r
r
squared.
squared.
So how do I, pi is it the 6? No.
No, that's the radius.
Oh, pi, isn't it pi, there's a number, there's a number for that, right?
There's a number for that on your calculator. So on mine, I have to do the brown key in 3, whatever it is for you.
Okay, what does it look like? Do you know? The radius?
Like this thing I put.
Oh, this little guy. Is that the- So would I hit second first before I do that?
Correct.
Second, and then the pi times 6 times 6.
I'm gonna actually not box this because that's not the answer we're actually looking for.
Did I do that wrong? Alright, so second pi, then I just do times
6 times 6.
You didn't do a times after you're saying.
Okay, so I goes that.
Actually, you don't need a second. Your pi key is just a key.
Okay, pi.
Times 6 and 6. There you go.
Okay.
So the whole circle is 113 square centimeters. And again, my clue for you is to continue these cuts. If the whole pi is 113 calories, then how much is the blue shaded area? And we'll go over it Monday if you can't get it yourself over the weekend.
Okay, so the 113 is not the whole answer.
No, that's the whole pie. You're not eating that much pie. You're just eating most of the pie.
I gotta practice these. I'm probably sorry. Okay.
You want to draw number 5 also?
I have circled. I did the, if I knew the things on top of my head, I would probably know what it was.
So a whole circle.
What would be 6?
Whoops, let me make it look the same size.
Nope.
So here we want the distance around the circle formula. That was this one here where we wrapped things around our arms. Remember that? So how many times does the width of the circle? Come on,
So
picture
it would
it
be
that
pi
way.
times the,
So it's pi times diameter.
so which would have been 8.
So for the whole circle, circumference is pi times diameter, which is about what?
Okay, so I go 5, 25.
So about 25 feet.
So that's all you do for that?
But it only wants halfway around the circle. So what's that going to be?
So you just divide by 2.
Yeah. So this is about
Well,
12.5 feet.
yeah.
And then we have to get back to where we started.
There's a lot of work.
So that's going to be 8. So our perimeter that's really here is 12.5. And 8 feet. So about 20.5.
Oh, so you had to add that.
Yep,
That's
because
gonna make a lot of work. just for that
perimeter
little
is the
thing.
distance around. And it is a fair amount of work. Circles are clunky. Right? I have to find the distance around a whole circle with the formula. Then I have to think to myself, hey, whoop, wait a minute. Hold on, I'm not going all the way around. I'm just going halfway around. So that was the divided by 2.
And that made the 12.5.
And then I have to say, whoop, I'm not around my shape yet. That just got me from here to here. I also have to get back where I started.
So how would you write that down as the equation to get to it? Like, is there something like, you look at that and I'm like, is there an easier way to be like,
There's not an easier way. There's a slightly write more way. What I recommended last class was you always start these with a plan
okay, I
that
remember that.
says, I'm going to first do that, and then I'm going to do that. And once you have a plan, then you can translate
Okay,
each
so
term.
what my question is gonna be, what do I need memorized so that I can pass these on?
You're
my
going to test all those formulas we've been using. The
You don't have a
circle
little
formulas.
cheat sheet that I can write
That's
them
your
down?
job to make the cheat sheet.
So I have to go back to that whole thing and look at it over again. I wrote some of it, but like, I feel like you should just have this little cheat sheet that you can tell me, like, remember all this.
Mhm.
And then I'll remember it all, and then I'll know everything on my test.
One of your classmates might have a good cheat sheet. So one thing you can do next week is,
I have
See if you
some
can
of the
remember
things
these.
that I need.
I can send out an email actually, put something on. But I'm not going to give you a cheat sheet. You can have good cooperation. But
Good cooperation.
I'm gonna call it a cramming sheet because it's not really a cheat sheet.
Well, because it's not that I'm gonna be able to use it on the test, but like, when I'm studying, like, I know, I've been looking at like the cups and the King Henry thing, so I know that. And then I have to remember, whatever that one you did today, that like a mile equals 5,000.
5,280 feet in a mile.
I have this sloppily written throughout my stuff.
Which is completely normal. It's just part of getting ready
Well,
for the
'cause you
final
go really
list to
fast in
extract.
class, and then I'm like writing it down, and then you move to the next thing, and I couldn't keep up, so, yeah.
Well, then you should have been slowing me down.
Right. Let's just pray for me. Whew. I need to work on all of that. And I'm gonna go print up a bunch of tests and I'm gonna practice them. I'm coming in Tuesday.
Remember, you can be done with homework if you just take lots of practice tests and show me that you can write these out nicely. Right? 20 neatly written problems was all you
Okay,
needed.
so I'll work on that.
So, and if you do a bunch of practice tests, you will have more than 20 nicely written problems. So it's not any extra work.
I think I'm able to check one more homework. Yeah. I'm gonna make time this week, and I have a funeral to go to tomorrow. But I made sure I get back Sunday and
Okay, back to the no calculator test. The next question was numbers 13 and 14. So first, a division problem. Oops, I don't want it there. There we go. And then an addition problem. Okay, division. I'm going to change the division to multiply by the reciprocal. Flip and multiply. Now I could just multiply across the top and multiply across the bottom, but those numbers will get needlessly big. So I would rather do some reducing. 5 times 8 is 40, so if I divide by 8, I get a 5 and a 1. 7 times 4 is 28, so if I divide by 7, I get a 4 and a 1. Now when I multiply across, 4 times 1 is 4, 5 times 1 is 5, it works out nice. For number 14, I want to add 3 things: 1/3, 2/4, and 8/6. And I should write it with some space before these pluses because I'm going to be putting some stuff there. So I need a common denominator. And maybe you can just look at this and say it's going to be 12. If you weren't sure, then how would you find the common denominator? We did that a lot going back to fraction, addition, and subtraction right there in the mad science thing. For this particular problem, the fastest thing is probably just to make lists. If we go 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 4 times 1, 4 times 2, 4 times 3, 4 times 4. For 6's, 6 times 1, 6 times 2, and as soon as you get something on all of the lists, then you can stop. The no calculator test is kind and doesn't give you giant numbers there. In any case, I want 12. So 3 times 4 is 12, 1, 2, 3, 4. 4 times 3 is 12, 1, 2, 3. 6 times 2 is 12, 1, 2. Whatever I do to the bottom, I have to do to the top to be fair. So I'm going to have 4/12, 6/12, and 16/12. Well, 4 and 6 is 10, and 16 more makes 26/12. I don't need to turn this into an improper mixed number. I can leave it as an improper fraction, but I do want to reduce my answer. If you really like mixed numbers, you could make it a mixed number. I don't care. Okay, so that was all of that one. Now it's the no calculator test 6, 14 we just did. Write something as a decimal. Okay. So fractions to decimal was just top divided by bottom. Can I reduce this? Sure, but it doesn't matter. I just want to do this. If I had a calculator, I could just look at it and say, oh, 6 divided by 96.0625. But I don't have a calculator. So I have to do some long division. Decimal point. Does 60 work? No. Actually, I'm going to back up. I do want to reduce this. I don't want to do things with such big numbers. I'm going to take this and divide top and bottom by 2. I can actually divide by 6, but I'm pretending I don't know that. So half of 96, well, half of 90 is 45, and then 3 more from the half of 6 would be 48. And then I can divide by 3. Remember your divisibility rules back from early on. Divisibility rules. So I can say 4 plus 8 is 12, so 3 is going to go into it. So 30 is 10, and then I have 18, so another 6 3s. Okay, now I can do 1/16 better as a long division. 1 doesn't fit. 10 doesn't fit. 100 will fit. How many times does 16 go into 100? It might be convenient just to start listing things out. 16 times 1, 16 times 2, 16 times 3, another 16, another 16, another 16. So times 1, times 2, times 3, times 4. So the 96 is going to be what fits best, which was the times 6. So what's going to go into 40? The 32. Not sure why that moved. Okay. That's going to go into the 80, and then we're done. Okay, so I had a long start, but even without that long start, this is still a pretty long problem. So it might be one that you save for last. What was the next one? That one we just did. 17, that's just might be confusing how it's written. This is asking you about the 1 plus trick and the 1 minus trick. So when we had the 1+ trick was there in mad science. If instead of a times 0.12 and then with adding it back on, remember all of that, you could just do 1.12 for a 12% increase. But all we're saying is that an 11% increase, you can do that by multiplying the original number by times 1.11, and the 1 keeps the original amount around. Or an 11% decrease. Now I'm not adding to 1, but subtracting. So I have to multiply by, well, what is 1 minus 0.11? So I'll think that to myself. So 11% more than 1, 11% less than 1. And 18, fraction subtraction. So a number minus 1/72 equals 1/8. What is the number? Well, I have minus 1/72. So to even things out, I need to do plus 1/72 on both sides. That will get y by itself and some answer. But I'm not sure what goes in there. And I don't want to try and add those two fractions in this little space right here, because that will mess up my flow. So I'll go off to the side and say, what's 1/8 plus 1/72? I can make both have a 72nd. I'm not going to talk about adding fractions since we just did that. And I'm not quite done. I need to reduce things. So half of 16 is 8, half of 70 is 35, and half of 2 is 1, so 36. I can keep going. Actually, I can do 4. Be faster. Okay, all for now. Yay, saved correctly. Okay.